Hello everyone, this is Ahmet Efetürk. Now we see question number 27. It states that to create a segment joining the hands of the two stick figures as shown below. What do you notice about this segment and the line of the reflections? First of all, if we see our uh, reflection, like if we do our reflection, like this is what comes. And after that, we want to join their hands from here to here, like if we join with the one line segment. So what we see, like this line segment, when I am trying to drag it, the distance of this point to the line segment and another point to the line segment doesn't change. It always same. And once these line points are uh, like the main points, like the parent points of these line segments, whenever I take them, it changes like our figures image and the pre-image size also. Like you see, like the arms are going longer or shorter. It goes like that. Even like it happens like this. It all depends on these line segments, the place like we are dragging to. Because I think like these points are the parents points of this line segment. On this line segment, just in case like if I want to make, for example, point C, just wonder like this point, like if we try to move, there is no difference. But this line segment, like I remember this from very beginning topic, the first lessons, like because they are the parents point. So this is what we see. What else is there? And the line of reflection. Line of reflection, like the being placed accordingly. You see, like when I make it smaller, like it also gets smaller. When I get it larger, it is also getting larger, and the ratio is not being changed. This is what I see because of the reflections. So another question is what? Another question is have some fun, create other pairs of the stick figures like we can do from very beginning maybe. Just if we do, let's suppose, like this, that will be maybe very classic shape, but while teaching geometry sometimes like this kind of figures like we use. So and after that kind of reflection, let's do like this, like almost touching. And this one is I mark it as mirror. And then now it is the time for this one to transform. Yes, reflect. Yeah, what we see is this point to this points, like the distance from this line segment to both points, exactly the same. And if I am trying to change it, you see what's happening. And then let's suppose if I select them all completely, sorry, like this, and then trying to move, both lines are, but I guess like this is a center point again. So according to this center point, like our shape is changing. Yes, like this is what I could see. And they describe at least three different properties of the reflections. So what we see on these reflections, let's go back to our picture. Like we can say that the image and the pre-image always remain the congruent because they are in same size, they are in same shape. Even if I'm just trying to change it to different direction, or the no matter, like I am playing with the pre-image or my own image, like it doesn't make any difference. You see, like it happens like this, like the same shape. The shape is not changing, angles are not changing, the length of the line segments are not changing. So this is one of them. The other one, line segments which connect corresponding points is perpendicular. This is interesting. For example, from this point to this point, let's suppose I want to draw one line segment, and these line segments, for this line segment, if I want to make a kind of perpendicular, I have to choose one of the line point also. You see, like I want to make a perpendicular line, and this perpendicular line is, you see, like it is exactly parallel to our reflection line. So it shows that our corresponding points, between corresponding points, any line segment is always perpendicular to our reflection line of reflection. And the third one is what the distance of the corresponding points are same. So we can check, for example, I wanna keep one more point at the center. So let's label them. This is A, this is B, and this is C. Like it is a reflection of A actually. So between B, like between A and B, whatever is the distance, it's written here, and between B and its reflection, when we see the distance, it is absolutely same. There is no any difference. We can go for the any corresponding points, like we will come to the same conclusion. So we have described the three different properties of reflection also. Now it says that the drag a point on one of the stick figures and they describe what happens to the other stick figure. So does it matter which stick figure you drag and explain? Yeah, it is. Let's go back a little bit. Let's suppose like this point, if I want to drag, what I see is only related to this point, like the two line segments are there, their position is being changed. Let's see, instead of this one, like if I want to play with that, similarly, this one is related to 1, 2, 3 line segments. It is independent, but this one, the likewise, from another, like the pre-image, like if we try, sorry, like we double clicked, I guess, so that's why there's something wrong now. Yeah, the here also, like the what I see, it is same, like it is not changing. Yeah, this is what we see. So the other question is what, I guess like the 1, 2, 3, 4 more questions are, yes, explained. And another, like it says that are there particular angles of rotation to perform and describe at least the three different properties of the rotations. Like this one also, like maybe we can draw, but I will first tell what are the properties of the rotations. If we try to do a rotation maps a line to line, a ray to ray, an angle to an angle, and line segment to line segment. It maps. And secondly, rotation preserves the length of segments, because, for example, whenever we do rotation, like we will show maybe after a while, yes, we will show after a while. For example, this one we want to rotate, let's suppose with 90 degree, or let's suppose with negative 90 degree. Let's see what will happen. Yeah, it will come here. For instance, like we have rotated, what we see here, preserves the length, like the between A and this one also. Yes, for example, this one is point D, and this one is, and this one is what? Now I want to show the distance. I want to show between A, sorry, between A, like these 2 points, like whatever is the distance we see here between these 2 points, corresponding points, like the distance is the exactly same. There is no difference. So we can say that it preserves the measure of angles, and it preserves the length of the segments, and it maps a line to line, angle to an angle. This is what we can say. Thank you.